Hi OSLO users, we're going to continue our series on Gaussian beams and the tutorial associated with it. So this is the second video in the series. We're going to set up an optical system here, and it's going to be a catalog lens. So there are two slides here for what we're going to do. So here's the first one. I'm not going to read through it, we're just going to do it, but you can certainly capture the instructions here and then follow along as you're doing the tutorial. So this is the first of the two slides. And then here is the second of the two with the remaining number of steps that we're going to do. So let's dive right into OSLO now. So what we're going to do is we're going to start a new lens here. As we start the new lens, we're going to choose the catalog lens option. And I'm going to pick a name for this. And the name that I'm going to pick is just going to be Gauss Beam Example. You can name it whatever you like, obviously. For the magnification, we want to form a real image with this system, and we actually want to make the beam waist size smaller in image space than object space. So to do that, we're going to put in a magnification of minus 0.5. So we go ahead and we hit OK. So the next part is it says, okay, we want to pick a catalog lens, and I'm going to actually pick a certain Melis-Grillo one. It doesn't really matter which one you pick as long as it's got roughly the same focal length as I'm using. So here we are under the Melis-Grillo catalog, and for the EFL I'm going to just type in here 500, which is going to move us. Then I hit tab, and that gets us roughly to the 500 millimeter focal length ones. The one I'm going to choose is this 501.850. It happens to be one that's doubly convex. You could choose a plano convex if you like. One thing to remember from geometrical optics is if you use a plano convex lens, or just in general, if you want to minimize spherical aberration, you want to put the more curved side towards the further conjugate. Then you split the bending between the two sides a little bit better. So here I just go ahead and choose this one. If we double click on this, now we've got that lens in our system. Step E in our process, just to see that we have this lens, is to go ahead and click on the lens drawing window. I'm going to go ahead and make my window a little bit bigger here, and you can see we have the catalog lens in. We haven't done anything special at all in terms of setting this up or telling it that we've got a Gaussian beam. It just set up a system with a minus 0.5 and used the standard wavelengths. So step F tells us to go ahead, and since we're going to use a helium neon laser, we're going to enter a wavelength corresponding to the helium neon. That's one line that we have encoded in here, so you don't need to type it in. Of course, these are in microns, so it's 0.6328. So we click on that, and then we're sure to also delete these extra two wavelengths, since we're dealing with a system here that is ideally monochromatic. We hit OK on that. Next thing to do is this beam is a lot wider than what we're going to have, and even though this number doesn't really match the beam itself that we're going to be tracing, we go ahead and put 2 millimeters in here. So that just shows that now we're illuminating just the center portion of this particular lens the way we have it set up. And then we just set up an object height that's minus 1 millimeter. Now to do this, and we could have also done this for the entrance beam radius, we click here on our setup. So again, we come here, we click on the setup, and we have to do that because right now it was defined with a field angle, and I want to define it with an object height instead. We go ahead and choose minus 1 millimeter there. Again, this is not that meaningful of a parameter in terms of what we're ultimately going to do, but we do want to put a number in there, so when we run our paraxial analysis and such, we actually have some numbers that we can at least look at and make some sense. So we hit OK here. The next thing we want to do is run the paraxial analysis, and this is the paraxial setup evaluation. So we go ahead and run that. I'm going to make the text window here a little bit bigger so we can see everything. You can see the entrance beam radius and some of the other factors we've put in. Notice one thing though is our paraxial magnification is no longer minus 0.5, and the reason for that is we've actually changed the wavelength a little bit. So you might sit here and try to figure out what it should be, but you don't have to actually go in and do that. If we go back into the setup, and if you notice this when you first ran it, you might have been able to fix it right away. We can actually adjust the magnification right in here, and OSLO does the work for us to actually set it correctly. Oops, I put minus 5. We should have minus 0.5. So we now just set that to minus 0.5. I hit OK here. And now if we, I also often, and it doesn't say this in the instructions, like to clear this window so that the output I'm looking at is the latest data I have in there. You certainly don't need to do that. I right-clicked, by the way, to do that. It's also text window reset. There's other ways to do that. I just like to do it. Makes it a little bit cleaner in this case. And so now you see we do have a paraxial magnification of minus 0.5. And then the last thing that we're going to do here is we are just going to give this system a name. So I'm putting it in as Gaussian beam example. And this is in things like Windows now will have that, the little lens window drawings and things will actually have that now as the name. And I hit the green check mark because I like everything that I've done, and I'd like to be sure that I don't accidentally hit the X button and get rid of it. So if you are unfamiliar with the green check mark and the red X, then we do recommend watching the video that's associated with the details on that.